Our second presenter is John Batchelor. As a civil and structural engineer for over 30 years, John has a wealth of international experience. From founding Arup's Tokyo business in 1990, where he carried out some really interesting cutting-edge seismic design engineering projects, to leading multidisciplinary design teams developing major rail, tunnels, subways and urban infrastructure projects in cities as diverse as Copenhagen, Riyadh, Hong Kong, Bangkok, Toronto, New York and London. John's going to share a really phenomenal story with us today. So John, please take it away.
Thank you. I'm John Batchelor. Thank you for the introduction and for the opportunity to speak today. I'm here to talk about digital fabrication in infrastructure, where it's not yet the new normal. We're like explorers in this new territory. But one thing is clear, we should be exploring it together and not as single companies or individuals. So in infrastructure, the challenges that operators and owners face are their needs for maximum reliability, minimum maintenance, and of course, safety and continuity in operations. So how can digital techniques work for us in that environment? To tackle these problems, we need a multidisciplinary approach working together to make digital techniques work for us in infrastructure. So as an example, Arup and Costain began a conversation last year as collaborators about digital opportunities in the rail sector. We asked, is there opportunity for 3D printed brackets in a future urban tunnel project? And we looked at the Crossrail project experience in London, recently civil works completed here, for lessons on where to go next. Here you can see the rail systems supported on brackets, which are drilled into the concrete in sight, some manually, some by machine, and a galvanized steel walkway with adjustable struts, you can see on the left clearly, so it could be installed early, flipped out of the way for track work installation to suit program and sequence constraints in the tunnels. We considered how these tunnel designs have evolved from the solid mass concrete of the UK's high-speed rail project in 2005 on the top left, simple but with a lot of embodied carbon, through Crossrail in London, altered during procurement, as you can see from the next two pictures. Both the precast concrete walkway was altered to be more lightweight and the brackets altered from straight back to curved. This solved some problems but raised others. So we know that for rail tunnels in design now, around 2/3 of the embodied carbon is in the concrete, and that's after cement replacement measures. 10% of that's in the walkways if solid mass concrete is used. That's a lot of carbon. And the thousands of brackets and thick fixings are a critical part in program, particularly where you have to work in the constrained environment of the tunnel, where long objects can't be turned round. So, excuse me, we generated some ideas. What if point cloud scans of an as-built tunnel joints and geometry are made, and the point cloud transferred into BIM, giving precise locations, avoiding no drill zones at the joints, and allowing automated calculation of each bracket dimension to suit the as-built situation, ready for 3D printing. On-site cutting and adjustments then minimized. No spare parts inventory is needed, just the software to print it. And capital costs in the confined tunnel like this, of course, are defined by logistics and program rather than materials cost. So we're continuing to explore those possibilities with our collaborators. That's just an idea, but here are some built examples that give us clues into the next steps for digital fabrication in infrastructure. Firstly, on the left is a 3D printed footbridge made of stainless steel. This was printed by collaborators MX3D. This is certified for public use in Holland. This gives a green light of regulatory recognition to digital fabrication in the public sector, at least in that country. And on the right is a 3D printed drainage chamber in France. This was printed by X-Tree. It's made to measure for the existing pipes and the underground obstructions, so it allows installation with minimal road closure time. How vital that is for operationally critical situations, like major roads or aircraft runways, where operational continuity is the driver, not the cost of the printing. In the marine sector, we're exploring the use of 3D printed concrete or similar materials to create biodiverse artificial reefs. The example in Monaco below shows 3D printing by D-shape. Objects up to 4 meters in dimension have been printed at present. That's with today's equipment, not tomorrow's. The opportunity is not just about biodiversity, but also about creating ecotourism projects in damaged environments. And this changes our thinking, crucially, away from the traditional use of concrete blocks, as in the picture above, as simply something for wave energy absorption. So let's generalize a bit. Consider the generic factors that we face in trying to move from today's solution to tomorrow's solution in infrastructure projects. It doesn't have to be a tunnel, but I think what's in common is that there's 4 factors at work here. Firstly, of course, we need to solve the materials, safety and ergonomics problems, the technical problems. We need to consider the market and procurement factors, such as labor shortages that may be driving the choice of digital fabrication. We, of course, need to consider the optimization of logistics and program, and we need to develop digital tools to turn survey into fabrication, as with that idea to turn a point cloud of a tunnel survey into a BIM model and into a printed brackets. So, whether in water, rail, bridges, energy, we see that in every infrastructure sector, things are ripe for change, prompted by digital techniques. In infrastructure, digital is about reliability rather than excitement, maintenance and logistics rather than geometry, but the opportunities are there to apply digital thinking and fabrication to address skill shortages and keep our critical infrastructure operational. So where does your project sit? Join the conversation, talk about the future you see. We look forward to the discussion. Thank you.